Lovely to see you all, so excited to be back. So to begin with, Brad, we're just going to go through 4F.2. We'll come around, see how everyone's going. And then in the second half of the lesson, we'll have a look at 4F.3. So, like 4F, if you've been adventurous and you've gone ahead and had a look at the tests that we're up to, 4F, 1, 2 and 3 occupies a large part of what the unit is about. Okay, so a lot of it's just manipulating and rearranging these trigonometric identities. So let's go back to the unit circle really quickly and let's prove this one. Sine squared theta plus cos squared theta is 1. So what we have on our unit circle, we have a radius of 1, and we know that the x is cos theta and the y is sine theta. And so then, using Pythag, cos squared theta plus sine squared theta is 1. Right angle triangle, a squared plus b squared is c squared. Okay, so that's an identity that we're using, we're preserving, and then you can rearrange that to get other identities like sine squared theta is 1 take cos squared theta. Okay, so if we have 1 take cos squared theta, we can simplify that to be sine squared theta. And I've listed all of those at the top of your page there. You can have a go at proving some of them if you like. For instance, tan squared theta plus 1 is sec squared theta. That could be one that you have a go at proving in one. So let's get into these examples. So let's just expand the following. Expand and simplify the following. So we've got cos x take 1 squared plus sine squared x. So let's perform this expansion using the perfect square rule. We'll have cos squared x take 2 times cos x times 1. So we've got a take b squared, a squared take 2ab plus b squared, and then we have here plus sine squared of x. Okay, we're going to go along there and collect all the like terms that we can see. So here we've got cos squared x plus sine squared x. We can collect them together. That's going to be 1. And then we've got take 2 cos x, and then we've got plus 1. And so it simplifies to 2 take 2 cos x. Okay. Now, before we can, it's expand slash simplify, because we're not performing an exact expansion here. Here we're going to factorise 3. And we can see we've got 1 take sine x squared. And that's an alternative rearrangement of this, isn't it? Cos squared theta is 1 take sine squared theta. Okay, that's an identity we can derive from the Pythagorean identity. And so we rearrange this, we've got 3 times cos squared theta. 3 take 3 sine squared x, not theta. Simplifies to 3 cos squared x. Excellent. Okay, here we've got cos x plus tan x times cos x take tan x. So this is difference of 2 squares. I'll just make sure I've written the example out properly. I have. So remember, if you've got a plus b times a take b, a squared take b squared. So this is going to simplify to be cos squared of x take tan squared of x. Okay, and we could try manipulate that a bit more, but I don't think we can write it any more simply. So let's just talk about ways we can manipulate these things. Well, tan x is sine x on cos x, isn't it? Okay, so then if we wanted to write them with the same denominator, we can multiply this by cos squared of x. So I'm going to do that quite slowly. I'm doing cos squared of x on cos squared of x. Okay, if I multiply this term by cos squared x on cos squared x, I'm multiplying it by 1. So I'm not changing the value of it. And that's going to become cos to the 4x on cos squared of x. And over here we've got take sine squared of x on cos squared of x. Okay, now these have the same denominator, and so we can write them at the top. Cos to the 4x take sine squared x on cos squared of x. Okay, so it's not simpler, but it's an alternative way of rearranging it. And that's just to show you how we are going to manipulate some of these tan values. Okay, so full marks here, but just exhibiting how we can rearrange tan and put things together. All right, any questions about that? Cool. All right, last one. We've got 1 plus cotangent of x. There's two ways of expressing cotangent of x. It's either cos x on sin x or 1 on tan x. Let's perform this expansion just using FOIL. We're going to have sin x plus sine squared x plus cot x times sin x, and then plus cot x times sine squared of x. Okay. So in this one, because we've got cot x times sin x, I'm thinking straight away it's going to be useful to substitute cot x for cos x on sin x. Okay? That's what cotangent of x is. It's cos x on sin x. And we're multiplying that by sin x. And do the same here, cos x on sin x. Now is the cot squared? No, it's not. Times sine squared of x. Okay, and then we'll just go through and simplify. So this remains. Here we've got sine x at the top and at the bottom, so that'll cancel, and we're left with plus cos of x. And here we've got sine squared x at the top and sine x at the bottom, so that simplifies to cos x sine x. And that's as simple as we can write it. Yep. Okay. So that's 4F2. Let's get in and do the questions from them. Run around and see how you're all doing.